One of the ways you can manage the lifetime of a WCF service is via singleton. A singleton is a single instance of your service that handles all client requests. This might make sense if you have a resource that's a natural singleton itself, and then you have this service here that provides access to that resource. Now, because all client requests are coming into that one singleton instance, this may not scale well, and you'll have to build your own infrastructure around there to handle those requests. Another problem with singleton is shared state. You'll have to synchronize all access to that shared state because all of the client requests are coming in on different threads. To implement singleton in your service, add a service behavior attribute to the web service class and then set its instance context mode to single. I'll show you how to do that now. In this demo, you'll learn how to configure a web service as a singleton. You'll also see what the behavior of a singleton is. I'll do that through this solution, which has a few projects. Here's a service, and here are a couple clients that consume that service. The service is implemented with a field that's a list of temperature detail. The operation we'll be using, setTemperature, accepts a temperature, adds it to that list, and then returns the list of all of the temperatures that it's collected so far. What makes a service a singleton is this service behavior attribute where the instance context mode is set to single. This temperature detail type is a class that has both a temperature and a location, and data contract and data member attributes so that it's serializable and accessible by the client. The client itself instantiates a proxy to communicate with the service, and then instantiates a new temperature detail. It has a loop so that it can continuously add temperatures. Within that loop, we get both a location and a temperature. In each case, if the location is blank or we don't have a valid temperature, it breaks out of the loop. Once we have that temperature detail, then we can call setTemperature on the service through the proxy, passing in the temperature detail and getting back a list of temperatures. This is a list of temperature detail, and we iterate through those. And this is how we demonstrate what the behavior of the singleton is, because every time we add a new temperature to the temperature detail list, it stays there because you're working with the singleton. Both of these clients are implemented exactly the same way, but we need two so that you can see the true nature of the singleton. Let me run this. So here we have both of those clients, client number 2, client number 1. And I'll start by adding a new temperature detail. We'll add a location Denver, temperature 77. And here's the results from that list of temperature detail. Now let me go to client number 2. We'll add a new location, London, 68 as the temperature, press enter, and now look, here's London 68, but we also have Denver 77 that was added by this client. That's the behavior of the singleton, where you have a single instance with that shared state. I'll add another one down here to prove the point. And there we are. We have all of the entries that were added by all of the clients being returned. So now you see the behavior of the singleton, and you also know how to configure it. Another way to manage the lifetime of a WCF service is via sessions, called per session. A per session service handles multiple calls by a single client. Each client will get their own new separate instance of a service whenever they instantiate the proxy and make the first call. When the proxy goes out of scope, the service goes out of scope. During the session, the per session service will manage state for that client. To configure this, you would set the instance context mode of the service behavior to per session. That's what manages the lifetime of the service. Additionally, you have to set the service contract attribute with the session mode to required or available, and that configures the session mode of the underlying transport. So let me show you how to go configure a web service as per session. In this demo, you'll learn how to configure a per session service. You'll also learn about the behavior of per session services. To get started, let's look at this web service. There's the set temperature method that accepts a temperature and returns a list. And this service itself is set up with the service behavior attribute, but its instance context mode is set to per session. In addition to configuring the service class, you would configure the contract. Here's a service contract, and its session mode is set to required, meaning that you must have a session. Additionally, you can set this to allowed. And allowed means that you can have a session if you're configured properly for it. Otherwise, it defaults to per call. If you set not allowed, the service will operate as per call also. But I'll set this to required. If you're working with per session mode, you should also configure service to support transport mode security or WSHTTP with message. Here I'm using transport mode. Notice the NetTCP binding. I have a separate base address to support that also, and so it's configured properly. The clients will request details for the temperature, call the proxy, get the list back, and print it out. But what you can expect to see here is that each client has its own separate list because it has its own per session web service instance. I'll run this and show you why. So here are the two clients, client 1 and client 2. And on client 1, I'll give it a location. And on client 2, I'll give it a different location. Notice that client 2 only shows London. Client 1 only shows Denver. So let's give client 1 a new location and temperature. There's client 1. It has both Denver and Bangkok as its two temperature details. However, it does not have London. That's because client 1 is using a separate instance. However, it's using the same instance on every single call. That's why we're maintaining a list here, so that we can get the temperature detail from the previous call and the current call. Same thing here, just to prove the point. There are separate temperature details for this service also. So that's the behavior of per session services. Another way to manage the lifetime of a WCF service is per call. With per call, every single request creates a new instance. Even if you have the same client that calls that service, every call from that client on that same proxy will always create a new instance. Per call is the most scalable because every request is being serviced by a new object. Per call is also the default instancing mode. So if you have a per session service that is available but not configured quite the right way, or it's not configured with the proper session mode, then it's going to default back to per call. You can set up per call by configuring the session behavior attribute on the class with an instance context mode of per call. Of course, that's optional because since per call is the default mode, you don't even have to do that. So let me show you how per call works. In this demo, you'll learn how to configure per call services. You'll also see what their behavior is. I'll start off by showing you the web service. Notice that I had the instance context mode set to per call. This is optional, as I could just leave it off and it would still work as a per call service. Also, over on the service contract, I have the session mode set to allowed. This is because I have the service configured with a NetTCP binding, and NetTCP binding is an inherently sessionful binding transport service. However, the configuration of the session for the binding does not affect the lifetime of the service itself, so it's still a per call service. So let me run this and show you. So I have two clients here. There's client number 2, client number 1, and in client number 1 I'll type in a location, Denver, and give it a temperature. Now I'm going to stay on client number 1 and I'll show you the behavior of the per call. I'm going to give it another location, London, and a temperature. And notice that Denver did not show up. That's because every time I call that service, I get a new instance, a brand new instance. And so it doesn't remember that I put in Denver the last time, because when I added Denver the last time, it was added to that instance. And after I was done, after the return value of that instance came back, then that instance became eligible for garbage collection through the service, and then the next call that I made created a brand new instance, which had an empty list of temperature detail. Same thing here, client number 2, we can expect the same type of behavior. I'll put in a location. And so we have that value right there. Notice that it doesn't have anything from the client 1 input because, again, this is a separate instance. And let me demonstrate. There, we have Frankfurt. It did not remember the fact that we added Bangkok the previous time. That's because every single call is a different instance, and all you get back is what you put in. And that's how you configure a per call service.